you very much for the introduction, Christos, for this very nice way to start the lecture. And it's my pleasure to be here in Italy, in Sorrento. What a beautiful place. Wonderful to stay and share science with a very, very good views, which is fantastic. Well, I'm going to talk a little bit about oocytes. If they were asking me about the quality and what we can learn from the lab from that perspective. This is the intention of my lecture, talk to you a little bit about the effect of the quality related with the age and any other parameter, and finally also with euploidy. So I will show you how we normally evaluate the quality of the oocytes by the embryologist. It's some advances that we have been reached going through time-lapse technology, the dysmorphisms that we can see, and the automatic platforms that are available, and at the end some relations about the quality of the oocytes and stimulation protocols. So regarding morphology, there are many aspects that you can evaluate about morphology related with the cytoplasm, the extracytoplasm, and even polar body alterations that you can see in the microscope, which are some of them relatively easy to identify. But what we have realized is that when we take a look to the correlation between the embryologists to make an agreement about a score, if we want to give a score to an oocyte, normally we are in totally disagreement. If you see these 10 embryologists taking, these 4 embryologists, taking a look to oocytes, and you see the scores and the level of coincidence, normally is around 30% more or less, so it's relatively low. Even if we go to a simple evaluation, let's say that I want to say this oocyte is normal or not, the level of agreement between the embryologists normally is around 25%. So in 25% of the cases, we are agreed that one oocyte is normal. In 75% of the cases, it's not the case. So then we have tools like morphometry to evaluate the morphology of the oocytes. And I tell you why morphometry is interesting, because you can let's see if the video works. You can use the screen and use the drawing tools to measure things like the thickness of the zona pellucida, or just the diameter of the polar body, the perivitelline space, or just the diameter of the cytoplasm. So you can take measurements, and let's say it's a way to quantify something about the oocyte. You are not, I mean, you don't know what is going on behind this, but at least you are able to quantify that with these tools. To give you some examples, for example, and related with the age, and we were talking about the oocyte aging, there are differences in the perivitelline space between the oocytes. The older normally, or you see difference in the perivitelline space, or even you can see difference in the zona pellucida thickness, for an example. But again, I don't know the reason behind. I see that there are differences in the morphometry if I measure. So that's a good example. The others, for example, is related with ovarian reserve or anti-mullerian hormone levels. And you see that, for example, the area of the oocyte is somehow related with the AMH. The more levels of AMH, we see difference in the area of the oocyte. And especially we see big difference in the cases with very low or low AMH compared to the other values. So another example of difference in the morphology measuring and doing morphometry. But then other technology came, which is time-lapse. And the potential benefit of time-lapse is coming through the evaluation. Why? Because you have videos, you can identify in the video different aspects of morphology of the oocytes, and afterward you can have like a direct link between this morphism, this change in morphology, and the consequent embryo development. So it's a nice way to find direct relationship between something that I have seen in the oocyte, and then I follow up the embryo development. So if we evaluate morphology, it could be a little bit more accurate. And regarding this, we have done many studies. This is one of the studies that we published a few years ago, in which we identify manually, but using time-lapse, some of the parameters of morphology that are somehow changed or have some artifact or some changes in the morphology, and can be related, for example, with the fertilization rates. And if you take a look there, the vacuums, for example, are related with lower fertilization in between others. Even you can take a look to the granular cytoplasm, you can see a relationship with fertilization. So direct relationship is between some alterations, but keep in mind that the embryologists were quite in disagree between us in order to identify what is a a normal polar body or presence of granulosity, and then the outcome in the embryo. So keep in mind that when we try to make a relationship between morphology and the outcome. And then we have AI. And with AI, we have platforms that are, first of all, easy to be implemented because you don't need to have anything else than just a microscope that anyone has in the lab for doing the ICSI. You need to have a digital camera, which is around 150 or 200 euros or US dollars that you can connect to your to the microscope. And after that, you just connect through your computer to a software. You take pictures of each one of the oocytes from the patient. After, of course, you have to denude the oocytes. And you can organize, for example, the oocytes if are for going to do vitrification. Normally, we vitrify 4 or 5 oocytes per cryotope. And after a couple of minutes, 5 minutes, you take pictures of each one of them. You upload all this information to a software, and the software will give you a feedback about the quality. The quality of that could be related individually with a score from 1 to 9.9, or even the quality of the full cohort. What I will expect of that cohort of oocytes in relation with the morphology or whatever that is evaluated by this technology. So definitely this is another way to, another way to evaluate the oocyte quality, which isn't related with the way that we do by morphology or based in our idea of what is a quality of the oocyte. You have a report, and in the report, again, you have information about each oocyte, or you can have a global information. So sometimes it's true when you see these pictures, sometimes you have like a quality control, which you don't have with the time lapse, because sometimes your microscope does not have enough light, or you need to put more, or you need to probably focus better. So these kind of things are in between the process of doing this type of evaluation. Okay, so we have two types of report. We have reports that are related with the quality of each oocyte individually, and we have a report of also the quality of the cohort. This score can be related with the possibilities of that oocyte to become euploid, but going to more simple, the possibilities to fertilize this oocyte or to have an ongoing embryo going to a blastocyst. And then you can have a report about the full cohort, what I should expect of that cohort in the number of blastocysts I will get, or the chance of those groups of oocytes to have a baby at the end of the cycle of IVF cycle. So these are the two tools available in this type of technology to give you a feedback about the quality. So we have been doing an evaluation of this technology. First of all, taking a look to the relationship between the score and fertilization. And if you take a look to the graphic, the higher the score, the higher the chance of that oocyte to be fertilized. You see from 68 to 85%. There are differences between oocytes that are fertilized or not. We evaluate the area under the cube. Let's say the capacity or the predictive capacity of this tool to evaluate fertilization, which is significant, but the area under the cube is very discrete, it's around 0.6. And this is coming even for a multivariable analysis. This is just for fertilization prediction. If we take a look to the blastulation, the chance of each oocyte to become a blastocyst, again, you see that relationship between the score and the blastulation rate. Of course, difference between those that are reaching blastocysts or not. And this is the blastulation rate, sorry, provided by the by the manufacturer, but this is not the blastulation rate that we get in our study. We did, of course, a logistic regression in order basically to calculate the R under the cube of the capacity of prediction. In our data set, we had patients, standard patients, we have patients that are coming from oocyte donation. We have also vitrified oocytes from donors. And in all the cases, the R under the cube used to be around 0.65, more or less, even taking into account other variables that are conditioning the outcome in a multi-logistic regression. So again, the prediction of blastulation is discrete. We try to take a look to this score and the embryo quality using evaluation of the oocytes with IDA score or in different type of patients, standard patients or donors or even frozen. And let's say there was some kind of relationship, not super direct, but at least significant. So our relationship between the quality of the oocytes and this AI score, very discrete, not very important. And finally, we will take a look to this AI image analysis tool and the capacity to predict euploidy. The numbers that we have still are very low. And for me, I mean, I see it's quite difficult that just taking a look to oocyte, you will be able to predict the euploidy, the chance of that oocyte to become in a euploid blastocyst. But we didn't see any significant relationship because anyway, the data set is very low. Of course, there is a relationship between the quality of the blastocyst using, for example, IDA score and the euploidy rate. But with the oocyte euploidy prediction, even that there was some kind of relationship with the numbers that we have right now, we didn't see any relationship at all between this prediction of euploidy and the final euploidy of the blastocyst. This is the RS under the cube, again, not significant and very limited, nothing to do with the IDA score, which is related with the blastocyst quality. So in summary, with this tool and with the numbers that we have that still are limited, we did not see any relationship between the score and the chance of that oocyte to become in a blastocyst that will be euploid or not. But this technology can give you an evaluation of the score of the cohort like itself and then make a live birth prediction. And we tested also, again, our numbers are not very high. Keep in mind that together with the evaluation of the quality of the oocytes, you include the age of the patient, and it gives you several probabilities. The probability to have at least one blastocyst, a most probable interval of blastocysts that you will achieve, and then probability to have at least one live birth. So we evaluate this. Again, our numbers are not super high. So this is at least the probability of getting one blastocyst and then the probability to get one live birth. The numbers are not, the data is not significant. The numbers are very limited. If we take a look to the probability to get at least one blastocyst, this is easiest. There are cases with no blastocysts, very few, but there was significant difference in the score. This is the probability to get at least one blastocyst and the possibility to get at least one useful blastocyst. So in both cases, there was a relationship. The study was done, again, with 50 patients yet. And there the cube is high because at the end, what you are predicting is something like very dramatic. If you're going to have at least one blastocyst from that patient or not. And then in between that, you have many possibilities. If we go to a little bit more detail, which is the most likely blastocyst range, you see here the predicted blastocysts of each cohort and the blastocysts obtained, so it's a little bit pessimistic in general. The most likely range of blastocysts and the actual in 50% of the cases was in the right range. In 23% was above the range, so we get more oocytes that were predicted by the tool, and only in 20% of the cases, the number of blastocysts was below. So in general, it's pessimistic, so it's quite possible that when you give that prediction to the patient, in 80% of the cases, that prediction will fit or will be even better. And only in 20% of the cases, the prediction will be below. We have done this with total blastocysts and with useful blastocysts. And in both cases, the capacity of prediction was around that 50% matching, in 20% was lower and 20% was higher. So finally, also we take a look to the live birth prediction. Again, our numbers are very low, so it's difficult to give you some feedback, a part of the feedback that can be provided by those that develop this algorithm. But in our case, we see, of course, difference, but still the numbers are very limited, so I don't think that this information right now is really useful like it is now. And then we can take a look a little bit about the contribution of stimulation protocols in the laboratory. I would like to tell you a little bit about what's going on from the lab perspective when we receive the oocytes, depending on the stimulation protocol. And there are many things that we can do around that, related with embryo development for sure, with blastocyst development, the quality of the blastocyst using AI technology, because at the end, in the lab, there are many things that are conditioning the quality of the embryos. Some of them related with the patient like itself, some of them related with the conditions that we have in the lab, some of them related with the stimulation protocols. And I would like to underline this part of the study. First of all, going to some studies published in the past by my colleague Elena Labarta, just showing that there was no relationship between the amount of gonadotrophins and the aneuploidy rate, the total dose, or even the number of oocytes. The more oocytes you obtain, not the higher the chance to have an abnormal or an euploid embryo. We did several studies about the use of stimulation versus natural cycle. This is a study that was published by Elena Labarta again a few years ago, comparing the same patient with a natural cycle or stimulated. in which we basically demonstrate that there was not a higher incidence of aneuploidy, or in other words, when you stimulate a patient, you do not increase the risk of obtaining an aneuploid blastocyst. And of course, we did any other studies related with the quality of the oocyte. This is a good example, a little bit more non-invasive. In this case, we measured the oxygen consumption of the oocytes and the embryos, and we demonstrate in that study that the higher was the amount of oxygen that the oocyte or the embryo were using, the better was the quality. And in particular, we did a study in oocyte donation in which we demonstrate that depending on the type of stimulation that we use for our donors, the oxygen consumption was significantly different. In fact, in that study, we observed that using only recombinant FSH, the levels of oxygen in the oocytes were higher. If we go directly to the quality of oocytes, keeping in mind all the technology that I have explained to you, that we can evaluate just the morphology, we can just evaluate dysmorphism, we can evaluate the quality of the oocytes using time-lapse, or even we can do morphometry, but also we can use AI. So we try to make a comparison of the quality of the oocytes depending different stimulation protocols using this technology and taking a look to the score. And also we take a look to the embryo quality using another score of AI. For example, if we take a look to in this study in particular, this was a retrospective study that we include around 300 patients. This is part of a PhD program study of one of our embryologists in Valencia. We make a comparison in between the score provided by these two types of protocols using HMG or using a combination of two recombinant FSH and LH. And we saw the level or the average of the score with significant difference under these two situations. We observe a higher score of the oocytes or better quality of the oocytes when we're taking a look to the patients that were coming from an stimulation that we're using this combination of these two drugs. And we have used many technologies about the evaluation of embryo quality. This is one of them, which is called Embryology from France. Actually, this technology is no longer available, but it's able to work with videos and with images of embryos. But we were trying this technology to evaluate also the quality of the embryos. And this is how it works. Basically, it's like any other time-lapse technology. You have the time-lapse, you put the videos in this system, and the system is giving you a score and is classifying your embryos depending on the chance of getting a good outcome, high, low, intermediate. So using this technology, we make also a comparison in this group of patients against 300 patients. Two groups, one using only HMG and the other using recombinant FSH and LH together. And we take a look at the score of the embryos. What we did in this is the distribution of the population or the quality of the patients on how they were distributed. The first thing that you can see is the number of eggs in this retrospective study was significantly different between patients that were coming from recombinant hormone versus HMG. But if we go to the embryo quality, we did several evaluations. First of all, we take a look to the useful blastulation rate and the proportion of top-quality embryos. And what we did was to group the embryos in different categories depending on the score provided by AI. So this binary 1, 2, 3, and 4 is related with the quality, going from the worst to the better. And inside of each quality using AI, we make a comparison of these two types of protocols, using HMG or using recombinant hormones. And as you can see there, in most of the cases, this data is still unpublished, we're working on publishing on this data, there was higher proportion of useful blastocysts or top quality embryo rates in the case of those protocols, those cycles that were coming from the combination of LH and FSH. We take a look also to euploidy rate. Actually, this data is partially presented in ESRE this year, and we take a look to the aneuploidy rate between these two types of protocols, again, grouping the embryos in the same category using AI, and then take a look to the aneuploidy rate. So our intention was to normalize the quality of the embryos, and inside the same quality, take a look to the difference between two different protocols. And we observed significant difference also in the aneuploidy rate that was significantly lower when the patients were coming with an stimulation with recombinant FSH and LH. So finally, to conclude, because I have shown you a lot of data related with the oocyte quality and also related with the stimulation protocols, of course, we have several tools to evaluate the morphology of the oocytes if embryologists evaluate morphology, we have a lot of disagreement between us. We have tools that may improve this evaluation of morphology, like using morphometry, making measurements of the oocytes, using time-lapse also to make a direct relationship between the abnormality and the outcome. But we have AI tools that may overcome this difference between us in the way that we evaluate the oocytes, and it's not outstanding. Si no me conectas, it's working now, I think. Wait, hello? Hola? No, it works yet. No, I was finishing. The final thing is that the AI tools at the end can overcome the difference between the embryologists in the way that we evaluate the morphology. So it's not nothing outstanding, but it's better than nothing, because the way that we evaluate the morphology like embryologists is almost nothing. We don't have agreement between us, which is very important. And finally, taking a look to the hormones, how important is the role of the embryologist in taking a look to the quality of the embryos and the eggs that are coming into the lab, depending on your work, like doctors using different stimulation protocols. So we are able to see difference between the quality of the oocytes and the embryos, depending on the stimulation protocol. So I think that in the next years, we're going to be able to provide you some feedback about the quality, and this interaction may help to improve the way that you work with the stimulation protocols and the way that we obtain this data in the lab. And that's all from my side. Let me introduce you some of the embryologists that are working with me in Valencia. This is the team of PhD students that are doing the research that is funded by European Community and the Spanish government. And that's all from my side. Thank you very much.